So hello everyone. Today let us consider scissor cipher. When we are going to consider scissor cipher, this is the general expression we are having. That is scissor cipher. In case of scissor cipher, we can express ciphertext as C equals E of K comma P. So where E represents encryption and D represents decryption. So here the plain text is added with key and then the value will be taken mod 26. Whichever the value we are going to get, that particular letter we will going to consider. And in case of scissor cipher, every alphabet will be given a number. So from A to Z, we will going to assign value from 0 to 25 in this manner. And now if I want to consider the actual scissor cipher, here the scissor, in case of scissor cipher, the value of K will be 3. So according to that, I can express ciphertext as C equals P plus 3 mod 26. Okay, so this was the key used by Julius Caesar. So as a result, we used to consider this as scissor cipher. But in more generalized way, we can express scissor cipher as P plus K mod Q. So in that case, K can be the value other than 3. This is how we can able to consider when we are going to consider general scissor cipher. So first, let me consider a plain text. Let the plain text P is equal to let the plain text P is equal to pay more money. Okay. So now how I can express in terms of number. So what I am going to do, I'll going to express the corresponding plain text in terms of number. So here the number assigned for the letter P is 15. So I'll be getting this as 15, and for A it is 0, Y it is 24, for M it is 12, and O it is 14, R 17, and E 4, again M 12, O is 14, N is 13, E is 4, and Y is 24. So this is how we can express the value the plain text pay more money. Okay. Now let the value of K is equal to 3. So the value of K is equal to 3 means I need to add 3 for all the alphabets. And after adding 3, if any number is greater than 25, then I need to take mod 26, because the final value of the alphabet what I'm having is 25. If the value is greater than 25, I need to take mod 26. So here 15 plus 3 is 18. So the corresponding ciphertext will be equal to S. And similarly 0 plus 3 is 3. And the corresponding letter what I am going to get is D. The letter is D. And similarly 24 plus 3 is 27. 27 mod 26, if I am going to consider, what I am going to get, the 27 mod 26 is 1. So according to that, the value will be B. And similarly 12 plus 3 is 15, which is P. And 14 plus 3 is 17, which is the letter R. And 17 plus 3 is 20, it's U. And 4 plus 3 is 7, it is H. And 12 plus 3 is 15. I need to consider the letter as P. Again 14 plus 3 is 17, the letter is R. 13 plus 3 is 16, so we are going to get Q. 4 plus 3 is 7. So H. 24 plus 3 is 27. 27 mod 26 is 1. So we are going to get B. So this is how we can able to get the ciphertext. And when we want to get back the plain text, what we have to do? How much we have added while doing encryption, the same key we have to subtract from every alphabet. So then we can able to get the corresponding plain text. Okay. This is with respect to scissor cipher. Suppose let me consider the decryption. So here again 18 minus 3 means I'll be getting back 15. And here 3 minus 3 means the value is 0. And here we are having 1. So 1 minus 3. Let me use this. That is 1 minus 3 is equal to minus 2 mod 26. Why we have to take mod? Because minus 2 is not assigned to any of the alphabets. So as a result, we need to take mod 26. So how I can get the mod value? It is equal to 26 minus 2, which is nothing but 24. So now we can observe that whenever the ciphertext is 1, the corresponding plain text is 24. Similarly, 15 minus 3 is 12. Here 17 minus 3 is 14. So for all these things we're going to get. But whenever we are having the value 1 or whenever the value becomes negative, then you subtract that number from the modulo, you are going to get the actual number. This is how we can able to decrypt the message using scissor cipher. Okay.